So the last section for the unit test is volcanic landforms. And reviewing from earlier this week, cinder cone, or the three types of volcanoes. And yes, the shield volcano is like in Hawaii, with lots of constant eruptions, making a big gradual hill. And who knows one of the other types of volcanoes? Excellent. So the cinder cone volcano, as the name suggests, made of cinders, layers of cinders. It tends to be very triangular. And we're actually going to talk at the end of this lesson about what exactly defines a cinder versus ash. The shield volcano, as was mentioned, you've got lots of runny lava over and over and over, making a more gradual, low-lying volcano. And the composite, of course, the word means it's made up of more than one thing. And you see here, ash, cinder, and bombs. Again, at the end of the lesson, we'll talk about what exactly those are, and lava. So you've got the big explosive eruption, followed by a lava eruption. And so you get these alternating layers, which gives you a big lumpy mountain of a volcano. Next, there's also a lava plateau, which is a lot like the shield volcano, only it's a plateau, not just a small shield shape. And so you've got that runny lava, and it's coming out of small vents and literally flooding out, making a kind of a plateau, a big flat layer area. And then it cools, and then it repeats. And the interesting thing about this is that there's a lava plateau, the Columbia Plateau, in Oregon, Washington State, and Idaho. That's how big it is. It covers those three states, areas of those three states. Here's a picture again from the textbook showing you've got lots of eruptions, and it makes a huge, huge area. And if you've ever driven through Idaho, you can actually see this. There's a bunch of like grass and scrubby stuff that grows over it, but you can see that it's volcanic rock, much like these chunks of rock we talked about the other day, lava rock, the extrusive rock, all over the place. And it's interesting because you don't see any volcanoes anywhere. And the reason why is it's a lava plateau, so it wasn't a huge volcano. But again, lots of volcanic activity in the past in that area of the country that we don't really think of as volcanic. The next feature is called a caldera. A caldera, think of the word cauldron, and so it's a big empty crater, a huge empty crater. And there's two fairly famous calderas. The textbook has a nice picture of how a caldera forms. Basically, the magma and lava blows out of the magma chamber. So the magma chamber is this big area underneath, down deep in the crust. And it ends up exploding out, exploding out, exploding out. And eventually, it all gets blown out, leaving a big empty like cave underneath. So the magma chamber is empty. Then the volcano collapses, leaving a huge crater. And so even though all this material collapsed into this, so this was really deep, this collapses into here, and you get this, it's wider than it is deep, but it still can be very, very deep. And in this case, Crater Lake, which is also in Washington State, and if you ever get the chance to go there, it's stunning. It's really strangely beautiful. And what happened here is there are actually mountain streams or whatever that have filled it up, and so it's a lake. And if I remember correctly, it's the deepest lake, deepest lake in the United States or in the world. Not sure, but it's a very deep lake. So Crater Lake, you also see that this shows the third step here is just calderas in general, or calderas specifically. Later, a small cinder cone forms in the caldera, and the caldera is filled with water. So right here, you actually have a cinder cone volcano. And if you see it, it's relatively steep. It is, you can see the rocks and the cinders. It's called Wizard Island. I don't know why, but that's what it's called. So you've got the cinder cone inside of the giant crater. And for scale, so you can see how big this actually is, there's actually a road that drives around here. And so it's a national park or a state park or something like that. And so you can go, there's a whole visitor center and everything, and you can drive this whole loop, and there's different places you can get out and hike and walk. But it is quite massive. And the other thing that's quite stunning when you're there, when you're here, and this picture it doesn't have good enough resolution, you can see out in the distance other mountains or calderas that also are in that area. And not too far from here, and in a minute we can pull up Google. I bet we could find them on Google. But Yellowstone is also a caldera. So you will also hear Yellowstone called the Yellowstone caldera or the Yellowstone supervolcano. And as somebody was asking earlier, that's really the name of the volcano. That's part of the reason it wasn't recognized as a volcano to start with. It's very flat, and it's pretty hard to see, but there is a bit of a crater, a huge crater, and that's why they think it's such a massive volcano, that it was huge. It blew out everything inside of it and then collapsed, and there's magma building up under it again. In 7th period yesterday, somebody, on the video, it looks totally destructive. But on the video, somebody said, well, why would it necessarily all erupt at the same time? Well, it might not. Like earthquakes, if there's lots of little eruptions, it's going to relieve the pressure. If it builds up, and then boom, it's going to be much huger and more devastating. So we don't really know. It's all just kind of speculation. All right, now a few more features. These features that are listed here are all features that are formed from magma. So while it was still underground, it cooled. And then the crust above it later, obviously, volcanic rock is very dense and very hard, and so it doesn't erode very quickly. So later the crust above it erodes away, and you see these very interesting features. And here I think you guys might see some familiar features. You could have something called a volcanic neck. Now these are very distinctive, and we actually see a lot of these around. So you can imagine, here's the volcano. The magma and the lava is coming up primarily through the main vent, right? And maybe some of the other vents. And then it's no longer active, and then this stuff erodes away, and you're left with this very strange pillar. And that's called a volcanic neck. And then you have sills, which might have formed over here on the sides. Sill, like windowsill, so they're going this way. And of course, they're not just sticking up in the middle of nowhere. Say this just partially eroded. And then the third one is called a dike, like a dam. And so that is where if the lava had come up vertically, and then the other stuff eroded away. So a neck, a sill, like a windowsill, which is horizontal, a dike, which is vertical, like a dam. And then the final one, I've got the picture on the next page, is a batholith. The batholith, think of like a bath, is the magma chamber. And so if it was all down in here, you're going to have a huge, relatively circular thing of granite, basically. And so Half Dome in Yosemite is a very famous one. And then a Dome Mountain, similarly, also a magma chamber, but not as round. So let's take a look at a picture that shows all of these things. Anyone ever seen this rock before? This is called Shiprock. It's in New Mexico, and you can see it from miles and miles and miles away. While you're driving down I-25, or if you head like towards Four Corners and you're out in like northern New Mexico, you can see it from ever away, and it looks like almost a big battleship on the horizon. This is not a great picture of it, but it looks more like this, and that's a volcanic neck. And so you can kind of imagine that if there was a huge volcano here, this is where all the magma and lava had come up and then cooled. And then the rest of this rock is relatively soft and erodes away, and it leaves that. And if you ever drive from here to Arizona or from here to New Mexico, you'll see it way out on the horizon, and it looks very freakishly strange. Like it just really doesn't belong there. And then you can see here also, and the picture in your book's much better. This is the dike. So it's almost like a wall here. So again, the lava came up through a crack, and then the rest of it eroded away. And then the sill, it comes up and comes out this way, like a windowsill. That is not a great picture. But you also, the thing that the textbook doesn't mention, there's something called columnar joining or jointing. And it's really fascinating, but when the lava all forms, and generally it's in the sill, you get this, it makes these weird like or hexagonal patterns like this. And so you'll see part of the cliff worn away, and you'll see these very, very regular vertical lines. And that's from the magma cooling. There's also a very prominent dike in Boulder, the Valmont Dike, which is out by the power plant. And so the Valmont Dike, you can see where the lava came up, and it's a fairly prominent feature that I think a lot of people don't realize is actually volcanic. Here again, as I mentioned, showing some pictures of this right here is Half Dome in Yosemite. This is the batholith, and again you can see, again, lithic means made of rock, and so this is the rock bath here. And again, probably there's been some uplift pushing it up, and then the other stuff erodes away. And then this shows you there are batholiths, apparently, all along this coast here. And here's Idaho, and Yellowstone's going to be right over here. And then the Sierra Nevada batholith, Baja. So you've got a tremendous amount of volcanic activity that happened here in this area in the distant past. And so that, of course, leads to some of these features that we see. Geothermal activity. Geo means earth, thermal means heat, and so these are features. Yeah. So these are areas, they're found in areas of present or past volcanic activity. So yes, hot springs like Glenwood, like there's some down near Durango. There's a lot of hot springs in Colorado. So it's an area of present or past volcanic activity, probably past volcanic activity in this case. But hot springs are heated water pools, heated by magma deep in the crust. And sometimes they have that nasty sulfury smell from the other minerals there. So we're all pretty familiar with hot springs. And you know, they can be very, very hot. At Yellowstone, there's some stunning hot springs, which they show the picture in the video. Last year when we talked about the archaebacteria, the archaea, living in those crazy extreme environments. Those are some of the hot springs in Yellowstone. And again, the video has some beautiful pictures of them. So geysers, and again, the most stunning geyser activity is in Yellowstone. This is one in Yellowstone. Steamboat Springs, I believe, was named for a geyser, a small steam or a hot spring or a geyser. Steamboat Springs does actually have hot springs. So the underground water heats up, becomes steam, becomes pressurized, and is forced out through small openings. And like Old Faithful is called that because it's very, very regular. It's so regular, they know exactly when it's going to erupt. And if you go to Yellowstone, there's big signs that say, oh, next eruption at this time. And it's really, really predictable over the past 100 years or so. They know exactly how often it's going to erupt. Yeah, they are. Some of them are extremely hot, like you can't go in them. I don't know how hot the geysers are. Obviously, as soon as it starts spraying out, right, it's going to start cooling down because like vaporized. But I'm guessing close in it would be very hot. And if you go to Yellowstone's, there's signs all over the place about, you know, don't be stupid and go stick your hands in it because you get burned. And then finally, geothermal energy. So in Iceland, which we've talked about, which is a volcanic nation, they actually use that volcanic activity and they take some of that superheated water, because there's a lot of it, and they pipe it into the homes to heat their homes. There's a type of heat you can get even around here where you have hot water heat, and it goes through little radiators and heats your home. Geothermal energy. So Iceland is using that to heat their homes. So you can imagine it's practically a free energy source, and you just have to harness it and pump it into the houses. Last slide, and then I'll come back to this if you need to take some notes. The last slide, and this is pretty easy. Here's a nice word for you. You guys who are enjoying our new words. Ejecta. Types of ejecta. That means something that got thrown out of the volcano. Again, this is really quite obvious, I suppose, but we give you these definitions so it makes sense when we're talking about things. So ash, like in the pyroclastic eruptions, ash is anything from kind of dust-sized to pea-sized. So the ash that comes out of the volcano in those huge clouds, like you saw in the video for Iceland, is ash. And then you have cinders, which maybe we could say would be like grape-sized to baseball-sized, and that's what's going to make up the cinder cone volcanoes. Cinders. Think of bigger gravel. Maybe instead of grape, you could say, bigger gravel. And then here's the best one, volcanic bombs, which they're not actually bombs that explode, but if one of these big chunks of lava comes flying out of the volcano at you, it may as well be a bomb. The volcanic bombs are basketball to Volkswagen sized, or, pick your car. And so then you might think, why in heaven's name would anyone want to live in the shadow of a volcano? You'll also see in the volcano video, they talk about in Italy, Vesuvius, which has had tremendous devastating eruptions, lots of people still living there. And in the Philippines and in Japan, all of these places, people continue to live by the volcanoes even though lots of people have died. And the reason is that volcanic ash, obviously not right away, but it makes really good fertile soil in the same way that forest fires, after it burns everything down, leaves a really nice, rich soil. It's the same thing. The volcanic soil is awesome for growing things. And so you end up with large populations of people living under the volcanoes.